Hey, what's up? So today I wanted to just talk about alg generation for FTO. So lately I've been experimenting and working around with algorithms for last three triples. So basically, like the last step of the solve, I'm just gonna do some like random moves and stuff. You have this where you're basically here, and you have these last three triple pieces or triples unsolved, and usually you'd solve it kind of like this. I guess here I'd do like an alg, but let's say you don't know anything, you just like solve it with sledges and hedges like this, and you pair them up and stuff. So you can do that, but that can be slow sometimes, and there's some bad cases. So I kind of wanted to generate algs, especially for the bad cases, because those can like just like slow you down a lot. So basically, I'll just talk through some of the challenges that I've been having. So you want to optimize the algorithm for ergonomics, right? And it's hard to figure out what's ergonomic on FTO because it's kind of an oddly shaped puzzle. It turns pretty differently to a lot of other things, so it's hard to figure out what's ergonomic. I've found personally, so there are two different types of grips. There's Ben's notation grip, where you have this corner in the front, and like this is R, this is U, this is L, this is F, this is D, B, BR, BL. And then I guess there's my grip, but like it's just because like I'm really the only one that has notation for this. So it's where you're like this with this edge in the front, and this is R, L, U, F, and then other stuff. So you can have two different types of grips. So you want to optimize algs for checking for both of those. So basically in this grip, like R, U, this kind of stuff, I found like R, U, and D to be the most ergonomic. I don't really think F is super ergonomic, like maybe in some circumstances. But basically R, U, and D. L is kind of awkward. B is bad. So yeah, you can do stuff like this. And then also, if you rotate here, you can do R, U, and D. And it's kind of different because, yeah, it's just different kinds of moves. So you want to check for both of those. So this kind of grip and this kind of grip. And then another thing to check for is when you generate algorithms, sometimes they swap pieces that aren't in last three triples. So when you're using sledges and hedges, the only pieces that you're affecting are these 9 pieces right here. But with algorithms, you can affect pieces outside of it. So for example, if I generate an algorithm, let's use this example. So let's say you have an algorithm to swap these two pieces, right? Pretty easy. But it also swaps these two pieces here. This wouldn't be ideal because when generating algorithms, let's say you have like, I don't know, I'm taking pieces out because I don't feel like setting up cases. Let's say you have this. So instead of learning an alg for this case, or let's say this piece was here, or this piece was here, instead of learning 3 different cases, you can just AUF through them. So this case can turn into a case where these two pieces are swapped by doing a U prime. However, if you have a algorithm that swaps these two pieces, if you do a U prime, it'll swap these two pieces, and that'll unsolve those. So you want to check for algorithms that don't do that unless the algorithm has like symmetry. So for example, if you have an alg like this, this alg, let's say it swaps these two pieces. If you have it like this, and you do a U prime, it's still the same algorithm. So you can have stuff that swaps outside of last three triples. So that's another thing you want to look out for. So yeah, just various stuff like that is kind of hard when generating algorithms. but I want to get full last 2 triples eventually generated, especially if this becomes an event or something. I'm probably going to mainly focus on the bad cases. So I decided that I just go ahead and walk through generating an algorithm. So here's a pretty bad case. If we have this, and then we set it up like this. Oops. This is a pretty bad case, right? So you've got these triples solved, and these two, like the triples are almost solved, but these two are off, and it's like the 2-flip case. So like I usually use like a Nicktoss kind of thing, like this, to turn it into a sledge. But here, it turns it into a 2-flip, and it's like a very bad 2-flip. So, well, I guess it's not super bad, but it's pretty bad. So I'll just generate this algorithm, or you can do 2-flip here and get the calm, but that's also not super great. So I'll just walk through generating an alg and how I do it. Okay, so to generate the algorithms, I use ksolve with a definition file made by Ben Whitmore. It's on his website. I'll link it down in the description. Basically, I have this template to help me make like the state, describe the state or whatever. So I do that, then I copy it into this notepad or .txt file or whatever, and then save it. And then I run it here, and it can take a while. So sometimes, like if it's like a 15 mover or something, I have it like running in the background or something while I do other stuff. But yeah, so then I generate it. Oh, lucky 10 mover. That's pretty good. So that will solve the case, basically. But as you can see, there's some wide moves and like FL, and it's just kind of awkward. So one sec. Okay, so basically what I can do is I can take this right here and just copy it. And sometimes there are more of them, so I usually like copy them here into the doc. But in this case, there's only one. And so I'd probably like copy it somewhere here. So yeah, but I won't do that now because there's only one. Then I have this program right here that basically, if you run it, and then you paste the alg in here. So there, and then what it first does is it gets rid of the wide moves. So you copy that, and it'll look for ergonomics. So usually you don't get anything, but you can just kind of like alter the code a little bit to get something. So like that didn't work. So I can take this out and then try this. So that first one was checking like basically this grip with like Ben's notation, but then this checks for like the edge and front notation. So you can check this and then run it. Alright, so oh, there we go. Okay, so this alg is optimized for R wide, U, D, R, and then BR. So if we just do the inverse, you can see, oh, there we go. So, R wide, D, BR prime, U, BR prime, D prime, BR, U prime, BR, R wide prime. So you can, as you can see on orange, we have the case in 10 moves, which is pretty good. And then also, I think if we hold it like this, the first alg we generated that had FLs is not that bad because you only have an FL at the beginning. So FL, FR prime D, FR prime U, FR D prime, FR U prime, FL prime. So that's actually not that bad. So here, let me quickly, now we've got to check to see like how it affects the thing. So if we do L wide and then do the inverse, so we can see that these bars get preserved. So that means the alg's good. So we see we have the same case, it's just off by an OPF, but these bars are still preserved, which is good. So now, if we just do the alg, so FL, it works. So that's a pretty good, that's a pretty good alg, and replaces like doing like 16 moves is what I would usually do with 10 like super finger trickable moves. So yeah, that's basically how I generate algorithms. Thanks for watching. I forgot to mention, just for demonstration purposes, if we go in here, sometimes an alg won't give anything good. So what you can do is you can go in here and start depth, and then go like a number above the number of moves that the first alg was generated at. So the first alg was 10 moves, but if that was bad, we do start depth 11, and then save. And you just go in here, and it'll generate all algs at 11 moves, and this can be helpful to just like find some better stuff. In this case, there's only one. Interesting. So then I can like do the same thing with this alg and see if there's anything better. The first alg was pretty good, but I guess I'll check this one off the later just to see if it has anything. But yeah, so that's generally how I generate algs. Sometimes it takes longer. Sometimes you have to check several like depths. But sometimes you get lucky and it's like a pretty good alg like this one, and you can save a lot of moves, and hopefully it helps. And yeah, bye.